Hey guys, welcome back to my CCNA 200-301 course. Patrice is here, and in this video we are going to review port bundling or port aggregation. Are you ready? Let's get started. First of all, let's see what is port aggregation or port bundling or port channeling or ether channeling. They're all the names that we call this technology is for, and how we can benefit from it. Let's assume that we have two switches here, switch 1 and switch 2. And we have a few number of clients that are connected to each of these switches. To be able to communicate between the left side and right side, obviously we need a communication between the two switches. But what would happen if this link fails? Obviously the communication between the left side and the right side will be disconnected. So what we can do, we can create another link between the two switches to provide some redundancy. So if that link fails, then we have another link that we can benefit from it. But in this situation, another protocol actually may create some problems for us. Not problems, it's a duty to react in these circumstances, because in this situation we can create a loop between the switches. We'll be talking about the spanning tree protocol in the future videos, but for the time being, just know that if you have a closed loop between two or more switches, then the spanning tree protocol is actually, the responsibility of this protocol is to make one of the links that is redundant to kind of offline mode, so you don't have loop in your switch. So this redundant link may cost us a lot of money. So our managers or ourselves may say that why don't we use it? We just leave it there to just react. If the first link fails, then we fail over to the other one. We are paying a lot of money. So in this circumstances, we can bundle these two interfaces together. So from a spanning tree point of view, these two physical links will become one logical link. So a spanning tree doesn't see two links anymore. It's just one logical link between the two. So first of all, we can have redundancy with port channeling, and also we can benefit from the redundant link as well. So for example, if this link is a 1 gigabit per second link or 10G link or more, and this one is also a 1 gigabit per second link, then we can have a combination of both. I mean the aggregation of both. So the performance will be increasing to 2 gigabits per second. So we have redundancy as well as a better performance with port aggregation. There are multi ways to bundle the interfaces. In general, we can divide them in two groups, static and dynamic. I'll start with dynamic. With dynamic, we are using port aggregation protocols. There are two port aggregation protocols, PAgP and LACP or LACP. PAgP or Port Aggregation Protocol is a Cisco proprietary protocol. So you can find it in Cisco switches only. But LACP or Link Aggregation Control Protocol is a standard, is an IEEE standard, and the standard number is 802.1AD. So with these two protocols, switches can negotiate about being actually having port channels or not, because there are some compatibility parameters that I will be talking about them in a minute that needs to be checked, and if those conditions are met, then ports can become in a port channel or port group. So with dynamic port channeling, we are engaging protocols to negotiate this process for us. And if everything is okay, then the ports can become port channel or they cannot become port channel. But with a static mode, actually, the switches will not negotiate about the port channeling. They try to become port channels. I mean, form the port channels between each other. But if those conditions do not met, then that link or those links may not come up at all. So you will be losing the whole communication between the two switches. But if you're using dynamic, port channels may not be formed, but the links will not going to downstate. So they will be working in individual situation. And obviously, a spanning tree will block one of them or more if you have more. So you don't have loop in your network. With both of these two protocols, you can bundle up to 8 interfaces. So 8 interfaces can be bundled together. But with LACP, you can bundle up to 16, but only 8 of them can be active. So at each certain point of time, only 8 of them would be active. So we say even with LACP, we can have up to 8 active ports, but you can bundle 16 ports together. So if one of those 8 links goes down and it fails, then one of the others, based on the priorities, will join to the group. So at each certain point of time, definitely you will be having 8 interfaces or 8 bundled interfaces in a port channel. When we use PAgP, which is the default protocol, when we configure it, which I will be showing you in the next video, we can have 2 modes. First of all, auto, and the next is desirable. As I mentioned, with these 2 protocols, we actually switches negotiate the communication to each other about being actually bundling these ports or not. Auto is actually in kind of listening mode. So switch waits for proposals to become having port channel on those interfaces or not. But desirable starts the negotiation about port bundling. So if one side is auto and the other side is desirable, there's a chance of actually a port channel forms. But if you set both sides to auto, no port channels will be formed because both of them are waiting for the other side to start the negotiation, but no one has started. So obviously no port channel will be formed. But you can have one desirable, one auto, or 2 desirables. Similar thing is happening for LACP, but the naming convention is different. In LACP, we call these 2 situations active, or modes actually, active and passive. So similarly, if you have 2 passive modes on each end, no port channel will be formed. But if you have one active, one passive port channel, there's a chance if those conditions are met. And if active, it's fine. Port channel, still there's a chance if the conditions are met, the port channel can be formed. The list of parameters that need to be met for a port channel to actually be formed is a long list. But at the CCNA level, you're talking about some most important ones. The first one is speed. So you cannot bundle one 100 megabits per second interface with 1 gigabits per second interface, or 1G with 10G. Both speeds should be the same. 1Gs with 1Gs, 100 megs with 100 megs, 10Gs with 10Gs. And also the duplex. The duplex of your interfaces in a port channel should be the same. So either half duplex or full duplex. The other thing is, if one side is access, I mean it's in access, the port mode is access, the other side should be access as well, and also all of the involving interfaces. Depends on the number of interfaces you want to have in a port channel. So all of them should be in access, or all of them should be in trunk. So you cannot have the combination of these two port modes. And also, if you are in access mode, your VLAN ID also should be the same. You cannot have interfaces with different VLAN IDs in a single port channel. Same for trunk. If you are in a trunk, you want to bundle trunk interfaces, those trunk interfaces should have similar allowed VLANs. We talked about it with the command switch port trunk allowed VLAN, you remember that? And also the native VLAN should be the same on all of those trunk interfaces. And the last item is the spanning tree protocol configuration. As I mentioned, this is not the inclusive list. There are more parameters that need to be met, but this is the things that you need to know for CCNA level. Alright guys, this was our today's video. In the next video, I'll show you how you can create a layer 2 port channel. I wish you enjoyed today's video and see you in the next one.